Dear Class 7 viewers, please welcome back today for science. I'm so excited today because we've been together since the beginning of our topic. Today, I want us to proceed with examples on potential and kinetic energy. And it is my sincere hope that today we're going to end up, we're going to finish the whole thing. It has been a number of days we're discussing the same, and let us today finish up so that next time we have something else to learn. Please keep on viewing and listen attentively, and I want you to follow me. You're welcome. So last time we talked about calculations on potential energy, and we looked at two examples, and I do believe you understood it. Today we are going to focus on kinetic energy, the kind of energy that a body possesses by a reason of its motion. When a body moves, actually, it has the so-called potential energy. It has the so-called kinetic energy. We say potential energy is for bodies which are at rest, those which don't move. Now today, quickly, I want us to focus mainly on the kinetic energy part of mechanical energy. As I told you, there are two forms of mechanical energy, namely potential energy and kinetic energy. So please go with me. Now, a body moving, any moving body possesses the so-called kinetic energy. And therefore, to calculate kinetic energy, we have a formula. And as I told you, the short form, the abbreviation of kinetic energy is KE. KE. And therefore, in our calculations, the most important part is formula. Without the formula, you cannot do calculations correctly. So the formula should be correct. And so what is our formula? Our formula is kinetic energy of a moving body, that is Ke, equals to a half mv squared. So our formula says kinetic energy for a moving body is given by the formula Ke, or kinetic energy, equals to a half mv squared. Now in this formula, letter M represents the usual quantity. So whereby letter M represents the mass of an object, or simply mass of a body in kilograms. Let us not forget that the standard unit of mass is the kilogram. So this mass is in kilograms. Then we have letter V. V represents the velocity of a moving body, velocity of an object which is in motion. So any moving body has the so-called velocity. Now, some of you might find it very new and confusing, but well, the term velocity means speed, or you can say velocity is displacement per unit time in displacement per unit time, or it is like speed, but this time in a specific direction. So with velocity, we do have a specific direction, but with speed, we don't have a specific direction. Therefore, velocity is a vector quantity because it has got both magnitude and direction. For example, 10 meters per second towards the west or towards the east, any direction. So velocity is the same as speed, not entirely the same, but velocity has specific direction. I hope this is clear. Now, of course, and Ke represents the kinetic energy side. Kinetic energy. That is the energy that a body has by reason of its motion as it moves. Thank you so much. Now, to understand the application of the formula, we do have 2 examples, and please follow me. Example number 1. Example number 1. Okay, before I go to example number 1, I said mass is always in kilograms. That is the standard unit of mass, the internationally accepted unit of mass. The standard is kilograms. Then velocity can either be meters per second. I'll put it this way. Velocity can be meters per second or kilometers per hour. Meters covered in 1 second or kilometers in 1 hour. These are the units of velocity, just the same as speed. And if that is so, and the kinetic energy itself is in joules. Very, very important to remember. Units are of very basic importance to know and to be remembered. Now, in our first example, the question says, a body, of course, a moving body of mass, a body whose mass is 96 kilograms, moves at a velocity of 9 meters per second. Find its kinetic energy. Find its kinetic energy. Find its kinetic energy. And that is our question. A body of mass 96 kilograms moves at a velocity or with a velocity of 9 meters per second. Find its kinetic energy. Thank you so much. So, as I told you last time, science has its own discipline. That is, there are procedures to be followed so that you go to the correct answer. And these procedures must be followed for you to be considered a smart performer, a smart scientist to be. So the steps are as follows. Now, solution, just like in mathematics, solution. Then we go to data given. What are we given there? What quantities are we given? And the quantities are normally given in specific units. Excuse me. For example, here, you write, okay, data given, or given data. Data given, in this case. Thank you so much. So the first data given here, our first data given is mass of a body. Mass. So mass of a body or moving body, which is small letter m, equals to 96 kilograms. Now, you have to be very, very careful with the units. Mass should be in kilograms and not otherwise. And then the second thing given, our second data should be velocity. Velocity, that is V, small letter v in fact, equals to 9 meters per second. And then, so required to find is the kinetic energy. So kinetic energy equals to what? Now, writing of data is very, very important. You have to write the data properly. So give it a question mark. What should be the magnitude of the kinetic energy of this moving body? Okay, fine. The second step should be the formula. Write your formula properly. And please do not forget rules of writing formula. A formula is an equation, so it has to bear 2 balancing sides. Two balancing sides. So in this case, our formula is kinetic energy for a moving body equals to a half mv squared. So make sure you write the whole formula. The whole formula. Kinetic energy equals to a half mv squared. And then from there, we start substituting our given particulars, the data, correctly. So the first step, Please, the arrangement is very, very important. Arrangement of work. You have to be very smart and yes, and well organized. So a half, of course, times the mass, which is 96 kilograms, substituted with the units, times velocity squared, v squared. So the velocity is 9 meters per second squared. The whole of this thing is squared. Now, something to note. Whatever is being squared in the formula is the velocity and not mass. Only velocity is being squared. So make sure when substituting, you don't square the whole thing. It is only the velocity. So 9 meters per second should be squared. And we all know the meaning of when a number is getting squared, that is a number times itself. So similarly, 9 meters per second squared means 9 meters per second times 9 meters per second. So, which gives us, in the second stage, as I always advise, you leave units because you might get confused somewhere during the process, which gives us the mathematical perspective of it, which is a half times 96 times 9 squared, which takes us to a half times 96 times 9 times 9, which gives a half times 96 times 9 times 1 times 9 equals to 81. Now next step is simplify. You would have simplified from here or at this stage, but I find it more convenient if we do the simplifications in this step. It's okay. So this is the 2, that is a half, and so the 2 by 2, 1. By 2 there, 48. Now remember, simplify is basically dividing. So we divide by 2. Which gives us 1 times 48 times 81. Which is very simple mathematics. 48 times 81 gives, if we do the calculations, gives, okay, so we have 48 times 81. Make sure you have a rough paper for the side work. You don't have to show the workings here. You see, after this working, I have to wrap this so that my work is left so neat. It is important. So which gives 1 times 8, 8, 1 times 4, 4, 8 times 8, 64, cut over 6, 32, plus the 6, 38. Adding this gives 8, 8, 8, 3. Yes, 8, oh, that's correct. So which gives us 3,888. These are joules, the joules. Now capital letter J represents the joules. Remember, the joule is the unit of energy. You conclude by saying, therefore, the required kinetic energy as per our question equals to 3,888 joules. This is the conclusion part is equally important. You don't have to take it for granted. Very important. So, as I said, your work should remain very, very neat. Very neat. Very, very neat. And I hope example number 1 is understood. And if that is so, please kindly allow me to proceed with example number 2. Example 2. I'll get this thing clear. Example number 2, very quickly. Now, in example number 2, because calculating kinetic energy is understood, then example number 2, I want us to hide one of the variables. Now, in this case, if kinetic energy is given or known, mass is known, you need to find velocity. Let us look at this problem. Very simple. Example number 2. The most important thing here is you following closely. Listen attentively, follow the procedures, and everything to do with the question. Very, very important. So question number 2, example number 2 says, A moving vehicle or vehicle, people pronounce it differently. A moving vehicle or vehicle of mass 45 kilograms has a kinetic energy of, has a kinetic energy of 360 joules. What is its final velocity? What is its final velocity? Or we have used the term, what is its average velocity? You see, because we don't expect a vehicle to move with constant velocity. It will have to change sometimes. It goes, increases that way. So let us go to a problem. Solution. Step number one, we read the problem twice, very fast, and then we try to understand it. It is very, very important. And then we go to the steps. A moving vehicle of mass 45 kilograms has a kinetic energy of 360 joules. What is its final velocity? So it's got the problem, that is data given. Of course, we have to collect the data given. In this case, we have the first thing given here is the mass of a vehicle. Mass of a vehicle, M, which is 45 kilograms. 45 kilograms. You will wonder, only 45 kilograms, it could be a toy vehicle. Some will say. We do it with cars and other big vehicles. The masses are normally big, like tons, so big numbers. 45 is a case. That's an example. And this vehicle has a kinetic energy of magnitude 360 joules. So the magnitude is 360 joules. Then velocity. What about final velocity? Velocity is just velocity, whether it is final or initial or average. It's velocity. Remember, units for velocity, meters per second or kilometers per hour, depending on how the question is given. Now, next step is the formula, our formula here. Now, since the question has one of these things unknown, the variable known as velocity, I prefer rearranging the formula so that we form an equation which can be solved very straight. Like kinetic energy equals to a half, so I'll begin with a half mv squared equals to kinetic energy. Now this is just the same formula, only that I have to rearrange it so that we get a very good continuation of the problem, in which therefore we start substituting in our formula. So we have half times the mass is 45 kilograms times the velocity not given, so leave it there, v squared equals to kinetic energy, which is 360 joules. So I hope this is the element is understood. Now next step from there is we now leave units so that we don't get confused in the process. We go to substituting the numbers, dealing with the numbers. That is the mathematics part of it, which is therefore the same as saying a half times 45 times v squared equals to 360. In this way it becomes a bit easier. Then we cannot simplify 5 and 45. So whatever we have to do is we multiply these things here, which gives us the 45 v squared over 2 equals to 360. I hope this is clear. This is a very simple algebraic question, and we can solve it in different ways. Either by cutting off the fraction, in which we multiply 2 on both sides, or introducing 1. After introducing 1 here, we do it by cross multiplication. Maybe you are familiar with this one here, so introduce 1, and then you do it by cross multiplication, which gives 45v squared times 1 equals to 45v squared, which equals to 2 times 360, giving us 45v squared equals to, of course, 720, that is 360 times 2. And then to get v as v squared, divide the coefficient of v squared, that is 45, on both sides. This one goes with this one here, giving us v squared equals to, then we have a simple calculation to do. 720 divided by 45, which I believe gives us, this is very simple mathematics, go to a side work, which gives us, okay, that is 145, I hope you're following. Then this one gives us 7, this should be 1, no, this should be 2, and we drop the 0 to make it to 70, which is 6 times. Yes, 6 times gives us 270. Therefore, v squared equals to 16. Now, we do have a problem here. Most of us get confused, but this is very, very simple. To get v, what we need is v and not v squared. So to get v, you under root. Take the square root on both sides. So, under root on both sides. This goes with this one there, so we have v equals to plus or minus 4. The plus or minus 4 is a mathematical perspective, meaning the answer can be negative 4 or positive 4. But so long as we talk about the speed of a moving body, then let us neglect the negative, and we say therefore v equals to 4. But each quantity, as I said, has its own units, and therefore the SI unit for speed should be the meters per second. So you write therefore v equals to 4 meters per second. Therefore, final velocity equals to 4 meters per second. That is the answer. I do believe this thing is understood. As usual, we clear the board so as to leave our working open and clear. Thank you so much if this part is understood. Most important thing is you revise. You have to revise these things so you don't forget it. And at this particular juncture, I would say our part is done. We are done with kinetic energy and potential energy. Find out on time and get as many questions as you can. Try solving them, applying the skills that I've taught you. Otherwise, I thank you so very much for listening, and please welcome back next time during our SAS lesson, where we shall discuss something else. Have a better day, good day, and please be precautious. COVID-19 is still a problem.